In 3.6, we're going to solve applications using inequalities. You don't have to necessarily use a greater than or less than sign for most of these, because you're always looking at whatever you get for the answer is what you're going to have to type in. I don't think on the computer that you actually have to do the sign for it, but I'm going to do them all with the sign just to show you what they actually mean. So the first one is going to be something like a taxi costs $1.30 for the first mile and $1.15 for each additional. The maximum that you have is $64.55. And it wants to know how far can you go on $64.55 to the nearest tenth of a mile. Okay, so what we know that we're going to spend $1.30 on the first mile, and then plus $1.15 times every mile that we're trying to find, and we have the total, and that's less than or equal to $64.55. So we can spend $64.55 or we can spend less. So we just need to solve. We're going to subtract the 130 from both sides. We get 115x less than or equal to 63.25. Divide both sides by 1.15. And x has to be less than or equal to 55 miles. So here, this is the tricky part of this question. It's saying that we're getting 55 miles, but we also have this first mile. So we have to add that back in. So our total is actually 56 miles. So remember on this one that you're solving for the additional miles and you have to add back the original first mile. Then the next question is that you're renting a car and you have a choice of place A, of cost A, where it's $30 per day plus 19 cents per mile, or B is just a flat $50 per day. And what you want to know is, when does B start saving money? So it's really asking, where do you catch up with B as far as how many miles you go? So we know that we're going to spend on the first one $30 to start with, and it's plus 0.19x, and that is greater than 50. So what we want to know is when greater than or equal to 50. So what we want to know is find out when this side becomes less than this side. So to solve, we're going to subtract 30 from both sides. We're going to get 0.19x greater than or equal to 20. Divide both sides by 0.19. And we get that whenever x is greater than or equal to 105.3 miles, that means that we're better off going with B, because that means that it is less. Okay, or if you just did an equal sign in there, that's fine, because you're going to get the same answer. The next type of question is for a job, and you have two choices. So let's say that the first job, you have the base salary of $13,000 plus a 10% commission. So these are sales jobs. And B, your base is $20,000 and you get a 4% commission. So the first one, you start with a higher base, but you get a smaller commission. The second one is you start with a lower base, but you get a higher commission. And the question is, at what point does A become a better choice? How much do you have to sell in order to have this be a better choice? So we're going to say 13,000 plus a 10% commission. And remember that 10, we're moving the decimal 2 spots, so it becomes 0.10x, and that's equal to 20,000 plus a 0.04x. So what we want to do is find out where these two equal each other to say, okay, at this point, we would rather start with less money to begin with, but with the higher commission. So we just need to solve for x. So I'm going to subtract the 0.04x from both sides and subtract 13,000 from both sides, which is going to give me 0.06x equals 7,000. Divide both sides by 0.06, and x is 116,666.67. So you have to sell $116,666.67 worth of whatever it is that you're selling to prefer to have the lower base salary along with the higher commission. So this is a good one to think about if you're going into a sales job. Most people that are sales people would probably go with this one because they think that they're good at it. And they think, oh, I can sell this much. And depending on what it is that you're selling, you probably could. Okay, so the next one is the amount that's in an account after so many years drawing simple interest. So our amount equals our principal, what we started with, plus PRT, which is the interest. And we did this equation before. But let's say that we're getting a 2% for 15 years. And we want to know what amount we need to put in order for A to be greater than or equal to 50,000. So the question is really asking, if we put in some money in it that's getting 2% and we're going to hold it there for 15 years, how much do we have to put in order to have $50,000 at the end? So our A is 50,000. And we want that to be greater than or equal to our P plus P, and 2% is 2 over 100, and our time is 15 years. So this is how you're going to set this one up. So the first thing we're going to do is factor out a P. So don't write this one as the equation. Start it with this one. So start it with P times, in parentheses, P1 plus 2 over 100 times 15. So basically, what it's going to be is A equals P1 plus RT. This is the equation that you're going to use. Okay, so now we just need to work all of this out. And we're going to get 50,000 needs to be here. 1 plus 30 over 100, which is 3/10. And that's going to be a total of 1310. When we do this, okay, so what I did here was I multiplied the 15 times the 2, which is 30, and then I simplified. 30 divided by 100 also becomes 3/10, And I said that 1 is 10 tenths, so I added 10 tenths plus 3 tenths and got 30 tenths. And then I'm going to multiply both sides by 10 over 13, because that is the reciprocal. So that means that we need to put in, and it's going to ask for the nearest dollar. We're actually going to get as our answer 38461.53, but we need to round that to the nearest dollar, so 38462. So we need to start with $38,462 if after 15 years we want $50,000 and we're only getting a 2% interest of simple interest. Okay, so the next type of question is going to be that we're going to charge $105 per meal. Our expenses are a flat, or our expenses are going to be $3,100, and we want to know how many do we need to sell to profit at least $11.40. So we know that we're going to spend, or it's going to cost $105 per meal. So, or we're going to get $105. So that's what we're bringing in. 105 times X. How many of those? But our expenses are $3,100. So we're going to take out the $3,100, and we want at least $11.40. So how many X's do we need to get when we're charging 105 minus our expenses to get $11.40? So I'm going to add the $3,100 to both sides. And I'm going to have 105x is greater than or equal to 4240. Divide both sides by 105. So x has to be greater than or equal to 40.4 meals. Now here's one that I talked about in a previous section on inequalities. We can't have just 0.4 meals. We have to have a full amount. But remember that we have to make at least $11.40. If we do 40 meals, we won't quite get $11.40. So we have to round this up to be 41 full meals. Even if this had been 40.01, we have to round up in order to get what our minimum is going to be. Okay, so the next one is, let's say that an electricity bill or a water bill is going to equal $29.93 per month plus a $330 per unit. What is our maximum unit if the bill can be no more than $70? So we know that we're going to spend $29.93 as the base plus 3.30x, because we want to know how many CCFs we can do, and it has to be less than or equal to 70. So I'm going to subtract the $29.93 from both sides, get 3.30x, has to be less than 41.07. Divide both sides by the 3.3, and x has to be less than 12.14. Now in this case, we have to have a full unit, and so we have to round this one down to 12. Even if we had 12.9, we have to round down to 12 because we can't have anything more than $70, and we have to have a full unit here. All right, so that is the end of section 3.6 and of chapter 3.